Okay, so that's some of the things we operate, and that helps the world science community and the US science community. That's what we do. Okay, now, where's research going? And how do you think about the future? Well, there's a lot of different ways to think about it. One of the ways I think about it is to ask what's happening to population. So it turns out that if there isn't a World War III, and let's all hope there isn't, and if there isn't another Spanish flu, and let's all hope there isn't, then these data historically are very, very accurate. They're very, very accurate. Population growth prediction is one of the most accurate sociological measures there is. And what you can see here is that the population growth from 1950 to 2000 was from 2.5 billion to 6.1 billion. In 2016, we're at 7.3 billion. And by 2050, we'll be at 9.5 billion. That's a huge increase over the course of about 100 years, more so than ever in history, obviously in total number of people. And you can see where the growth is coming. So let me start with Europe. Europe's going down. It's the only place that is. North America's going up, but look at the absolute numbers compared to Asia or Africa. Latin America's going up, but look at the absolute numbers. So if you are going to move the population in this direction by this much, and there's nothing to suggest that won't happen, what is the impact? And here's some examples. Everybody wants more energy. And we've been tracking energy demand for decades. Energy will go up at least 40% to meet that population growth. The number of people in cities will go up disproportionately high because people want to live in cities, because with the technology information age, they see what it's like to be near restaurants, social centers. So people are migrating to cities, and there's also a lot more people. And that's creating mega cities. So a mega city is a city of 20 million or more. And there are currently 21 mega cities. And there's going to be 43. The reason 23 doesn't just keep growing is there's some natural limits to how big a city can be and be effective in terms of transportation, movement of goods, and all sorts of things. So we think a lot about that. Vehicles on the roads, well, you can see what it's like now. This is going to double. And so right away, if you want to think about what to work on, you can start thinking about the impacts of just these. So the reason you hear so much about driverless cars isn't because they're fun. It's because the road usage is incredibly inefficient. And if you're going to double the number of cars, you can't do it with the infrastructure. And it's hard to change the infrastructure of existing cities because you can't double the number of roads. So you can start thinking about where to invest and what that means just by looking at top-level predictions like this. Food and water, obviously a huge problem. And you see that right now with poverty and starvation and water shortages, even in states like California. Now, this is not a doomsday story. I'm very optimistic about the future because history tells us we solve most problems. History tells us that. So I'll give you an anecdote. In England, in 1600, 1700, there were no trees left in England. No trees. So you hear about deforestation in Brazil. In the United Kingdom, there were no trees. Why? They'd all been cut down. Why? The fuel to reduce iron ore needed carbon. And trees were cut down, converted to charcoal, and that was used to make iron ore. They wanted to reduce iron ore to make iron. Why? Because the British Empire was expanding, and they needed more cannons, more boats, in order to get all of the economic gain they could by raiding other countries and getting spices and valuables. So as a national security imperative, drove an environmental energy impact for economic benefit. So what happened was, people knew there was coal in the ground. They knew about coal, and they knew they could use it. The trouble is, when you dug a hole, it filled with water. So the technology imperative of that era was to figure out how to pump water out of a hole. And that was the cause behind the invention of the steam engine. The steam engine was not invented to pull carts around a rail. It was invented to pull water out of a mine shaft so you could get the iron, so you could get the coal to reduce the iron ore to make your national strategy work. So necessity is the mother of invention. And we may look at these problems today and say they're very, very hard, but people will work and actively go to solve them. Global energy, huge demands on energy, and you see the effect. And we show a dramatic one here where you can't see across the road. The more subtle ones, of course, are the increase in carbon in the atmosphere that has all sorts of impacts on the world. And it's become a political problem, which is ridiculous, but it is. You know, people dispute what is happening. When nitrogen and sulfur were being let out into the atmosphere because of burning coal, the world eventually took notice, and we now scrub for nitrogen and sulfur. And that's what really has to happen with carbon. And we know how to solve that problem. At Battelle, we're actually pretty good at carbon sequestration, but it's been overtaken by politics and economics. So that's another example where you've got to get a bunch of things to line up. I've mentioned cars, you know, lots of them. So that's a problem that needs solving. Food. It's very interesting, as the world population goes up, the demand on meat goes up disproportionately higher. As the population grows and they move into cities, they want to eat more and more meat. The problem with meat is, if you do the energy balance, it's not a good story. You corn feed cattle, and you've just consumed a food source, and which costs a lot of energy to get there. Then the cattle themselves create a lot of methane, which is bad for the atmosphere. And so there's some very poorly thought out systems thinking about these problems. People look at a narrow piece of it, optimize it, and there's all these other consequences. So for those of you that are interested in systems solutions to high-risk areas, things like this need attention.